Let's say we have to integrate this rational function which has an unfactorable polynomial on the top and an x plus 1 to the third at the bottom. This video will be a guide on how to use partial fraction decomposition to split the integral into 3 easily solvable parts. But there's another method that personally I'd prefer to use to solve this problem, polynomial long division. Anyways, we can do that some other time, but let's start by just focusing on the rational function, which I'm now highlighted in light blue. Now, let's set this rational function equal to 3 partial fractions, one with a denominator of x plus 1, one with that to the second power, and one with that to the third power. The numerators are unknown for now, so let's just set them to a, b, and c. Now, we want to solve for our 3 unknown variables. So the next step is to multiply both sides of this equation we just made by x plus 1 to the third power. What this is going to do is it's going to make an equation that is much easier to plug numbers into. Start by setting x equals -1 because that would be really easy to cancel out 2 terms. Plugging it and solving, we see that c is equal to 3. Let's set x to 0 and see what happens. Cool, that gives us one clue to solving a and b. We need one more clue, so let's set x to 1 and solve. Now we have a system of equations. I'm just going to pull those two over here so we can be more organized. From here, a bit of algebraic manipulation will allow us to solve for a and b. And there's a million different ways to do this. What I did was solve for b in terms of a and then substituted. And now we have our answers, we can put them to the side and delete everything. So now that we've solved for our 3 unknown variables, let's rewrite our rational fraction, except this time with the numbers instead of the variables. And then we can put our integral back and split into 3 integrals that are easier to solve. Let's focus on one integral at a time. For the first one, I'm going to color it purple. Now to keep our work consistent, let's move it over here and let's put u equals x plus 1 to get rid of the denominator. And that's really convenient because du is just dx. Now let's apply the easiest integral rule, which is 1 over u equals ln u, and then we can set u back to x plus 1. Now the second integral is pretty similar because you're still substituting x plus 1 equals u, so du is still dx, but this time you're applying the power rule. And the third integral is just the same as the second, pretty much, because you're still substituting the same, except this time the power is a little greater. So once we rearrange everything to get the same thing, let's delete everything, which is really satisfying, by the way. I love coding this. And let's put everything in one equation. And there we go. There's our solution.